Welcome back to the hyperbolic coding chamber. The day it is unknown what day it is. It is unknown what day it is. It is unknown how long we've been stuck in this chamber. It's unknown how much further we will go. That being the case, we did have some comments, but I made the mistake of responding to them without okay, we can still bring them back. So you had a comment from Ronaldo Cruz. Awesome content. Discord link doesn't work. Had to manually type in. That is fixed. So that's unfortunate that was happening. I'm imagining the hundreds of thousands of Discord members we missed out on. So that's pretty unfortunate. And then we have Rising Dawn. Next time, don't put music. So I tried to put music in the beginning of the last two videos, and it was an absolute mess. So YouTube is dogging the little guy. I'm the little guy, and YouTube is dogging me. So I uploaded the video, and then it took like 3 hours to upload, and then it took like an hour to upload, 2 hours to process, and then it was blocked everywhere. It just said blocked in all territories. So then I had to edit it and then re-uploaded it, and then pretty much yesterday's two videos, they actually did them. I uploaded them anyway just for posterity, but it's pretty much muted throughout the whole video, which is really unfortunate. So I see now no more music. I'll try to see if I can find you kind of want to play the music that matters to you, so maybe I'll have to switch to just generic non-copyright music, which kind of sucks, but it is what it is. I guess I'm not really, maybe it's not Flames if it's just pure silence and me talking in these videos. So I'll see if I can find some other thing to make it more chill. Like then, that's going, maybe we'll see. We need some hype music because I don't want to put some chill, like some stream beats and it's supposed to be like the Coliseum, so it needs to be like a EDM, like dun, 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 like something hardcore. So I need to find a playlist like that is non-copyright, it's hardcore, and it's really gonna get the essence of the Coliseum. So the LeetCode Coliseum, at least that is. But nonetheless, we are here today. There's a really good article I read earlier on Hacker News, but I don't know enough to. Basically, the grind continues. And I'm gonna put the link for the article in the Discord, and I think I might mention it on tomorrow's video. But we're a little strapped for time today, and we've also had a lot of new people join the Discord recently. Also, I've been using ChatGPT, and I think they butchered ChatGPT. So I used to ask it a bunch of questions. It was basically my therapist, life coach, co-founder, and mother, father, and family structure. But then I think they butchered it because it's just not working as well. The answers I get have went down in quality. And some questions I ask will just say, oh, I'm OpenAI, I'm not allowed to say that. And it's just like, bro, they're kind of butchering the system. They need to turn the dials back and let us do what we need to. But that's unfortunate. I was talking to some people in Discord, and it seems like they might be experiencing something similar. So maybe we'll reach out to Adam Elon. Maybe we'll reach him out. We'll reach out to him and see if we can reach out to Sam Altman. I think actually he is in the Discord. So maybe we might just run a poll in Discord, and then he might revert that change for us. So that being the case, we are here once again. We've been doing a lot of good problems. I think we're kind of blasting through easies now for some reason. So I wonder why that is. Maybe we really are just entering the hyperbolic. Maybe it's like the episode in Dragon Ball Z where Vegeta's in the hyperbolic time chamber, and it's supposed to multiply the gravity of the weight that he's moving, but he's moving like he's on Earth. So then what I need to do is, I think he ends up turning the dial up. Maybe we need to turn the dial up. I think that's with mediums, but I don't know. There's something that we are extracting some value out of the easy still. So I say if we continue at this pace, we're doing like 3 or 4 easies a day. At this pace, multiplied over 3 to 4 problems a day. It should be like 90 problems a month. It should be like 90-ish problems a month, which means we should have finished all the easy problems in 4 months. Imagine the programmer will be then. We'll be unstoppable. I've also received some cease and desist letters from the competitive programming grandmasters, but we can't listen to those. We must continue. So that'll be like 500 or 600 easies that'll be done. So maybe that would be pretty cool, but I'll have to see. Can we wait that long? Well, has spent two. I mean, after I will there'll be no more easies left, which is kind of cool. So I don't know if anyone's ever done. Everyone, I'm sure someone has done all the problems in LeetCode. We know that to be the case, but I don't know if anyone's ever done them in this order. So now we can truly and finally answer the question. You can truly and finally answer the question, how to study for LeetCode. And maybe the answer is do all easies, but it's probably not. There's a golden ratio, but that being the case, we're just going to jump into it for today. So we're going to do our standard hour bit. And then also, you're going to want to check out the game dev channel. So there's another channel. It's the game dev channel. It's in the description, and you should join the Discord. So we'll have not only LeetCoders, but we'll have game developers, and some magic's going to happen there. Maybe we turn LeetCode into a game. Or, yeah. So you're going to want to join the Discord for that. So that'll be pretty cool. And yeah, we have some LeetCode to do as per usual. So now we can just jump into it. We had this problem in start value. I think we solved it. We did. So I'll delete that and go to the next one. Okay, sorry, I was setting it. It'll be a setting. We have a problem called Reshape the Matrix. So let's try that. So in MATLAB, there is a handy function called Reshape, which can reshape an m by n matrix into a new one. Oh, wait. With a different size RC, keeping its original data. You're given an m by n matrix mat and two integers r and c. There's also a similar function in NumPy or Python for data science. Two integers r and c. You're given an m by n matrix mat and two integers r and c, representing the number of rows and the number of columns of the wanted reshaped matrix. The reshaped matrix should be filled with all the elements of the original matrix in the same row traversing order as they were. If the reshape operation with the given parameters is possible, if the reshape operation with given parameters is possible and legal, output the new reshaped matrix. Otherwise, output the original matrix. So we should be able to tell relatively quickly whether or not the reshape is possible. For example, if m is equal to mat sub I, n is equal to mat sub I dot length, we're given at least a 1 by 1 matrix, which is important. The numbers can range, and row and r and c are at least 1. So it's possible that the matrix reshaping isn't possible, and I think the one way we can know that, as long as the sum of the total elements is the same for the requested reshape, it should be possible. So if we have an initial matrix of 2 by 2, we have 4 total elements. But if they ask us to reshape it to something like 5 by 1, we can't do that because we don't have 5 elements to put in one row. So for here we could check it's possible, otherwise return mat. And then from there we should be able to just place them into the output. So what we can check is if mat dot length times mat sub I dot length equals r times c, or if it does not equal r times c, we should just return mat. And we'll just return another empty array here just to test. And what I mean by I is 0. So we have 2 requested ones that are actually possible. So we should add one more, and the requested shape will be 2 by 3, and we should be able to pass that case. Okay, so we are able to pass the third case. So it seems for the reshaping, the reshaping, we'll have a new column, a new row, and a new column. So once we pull out an element, choose to make a new matrix. So if we're going from something like 2 by 2 to 4 by 1, we could just iterate through the matrix, right? And on each iteration, if we've reached the required number of rows, if we've reached the required number of elements per row, say 4 elements. Oh, no, this wouldn't be 4 by 1. This would be 1 by 4. If we reach, for each element, if we reach the required 1 by 4, right, then we will create a new row, right, and then continue adding elements. So in that case, it looks like we just have to iterate over all elements in the matrix and then add them to the new matrix. So we'll call this the new mat. It's going to be a matrix that is empty and starts with 1 row, right? And we'll have we'll let cur row equals 0. And cur call these are what we will increment. So now I think we just need to iterate over each element. So now we're iterating over each element. So how can we add them to the array? Right, we'll first have to check that we met the at minimum we have to have at least 1 element, right, to add. So once we reach the required column amount, then we'll add a new row and update the variables. Right. So how do we know that we can add an element, right? We'll have to check if new mat sub cur row index sub cur, actually if the length is less than the requirement for the number of columns, right, then we have to do new mat dot push mat sub row sub call, and it doesn't like this for some reason. Oh, I need to say new mat sub cur row index dot push, and then we can say cur row index plus, I don't know, cur call index plus equals 1. All right, and then if we check the same thing again, if we check for the current row index, right, that the length is equal to C, then we'll set cur call index equal to 0, and then we'll do cur row index plus equal 1, and new mat dot push an array. a new row. And so if we just try this really quick, the new reshape, wait, oh, this was my messed up one. We have a 2x2 matrix here. We want to reshape to a 1x4 matrix. So call index is never used for some reason. I guess you can shorten this actually by just saying call index, which is the same thing. So we're iterating through the matrix. We get to 1. We're going to say, okay, is 0 less than 4? Yeah. So we push 1 into this one. So right here, we do increment it by call index by 1. And 1 does not equal 4. So we go to 2. 2 is less than 4. So we push it on. 3 is less than 4. 4 is less than 4. And then we'll say, is 4 equal to 4? It is. We said current call index equal to 0. And we'd current row index plus equal 1 new mat dot push. So we don't automatically want to create that final part. We'd want to only do that if cur row index is less than r. Then we'll do new mat dot push to continue. I guess we should start it with an array. No way, that actually feels pretty good for a 12-minute run. So this would be n by m time to iterate through the matrix, as well as n by m space if we count the output as reusing space. But I don't know if they're allowing us to do this in place or not, but right. So even in this case, this is what we did. This this one with the division and modulus is very clever. So I have to keep that in mind going forward. That this is a possible outcome. So given an n by n binary matrix image, flip the image horizontally. N by n binary image, flip the image horizontally. Then invert it and return the resulting image. To flip an image horizontally means that each row of the image is reversed. Oh, I see what they're saying. Flip the image horizontally, then invert it. Oh, okay, so you just have to reverse each inner array and then flip every bit. So 0, 1, 1 becomes 1, 1, 0. I mean, 0, 1, 1 becomes 1, 1, 0, and then it becomes 0, 0, 1. So I think we can just code the steps. We create a function called reverse and invert, which takes an array of numbers and doesn't return anything. It'll just modify it in place. We get a left indice which equals 0 and a right indice which would equal r.length minus 1. All left is left, then right. It'll just flip the element. So we'll create a temporary variable which will store the value of r sub left. Since we're saving r sub left, we're going to replace it with r sub right, and then r sub right get the value of temp. Left plus equal 1, right minus equal 1. So this is the reversion. And then to invert it, why doesn't it tell me what the issue is anymore? R sub right is equal to, oh no. The arrays are actually numbers, so which is actually perfect. What's the problem here? R sub right is equal to 1, then return 0. It's going to give me the type error. Oh, I see what the issue is. And we can just pass in I wonder if it's one of those things where you can't do it in one operation or the output gets messed up. So if we have something like 1, 1, 0, we'd have 0, 1, 1. Ah, I see what's happening. I'm reversing it, but reversing usually skips the element in the center. So I think I see what the issue is. We'll let these equal the same. Then we'll have a special case. This is when they're not equal to each other. And when they are equal to each other, all we have to do is just swap these like so. Nice. So this would be m by n time, and we're not really changing anything. Oh, let me think about this. For each row, we iterate over all the elements. It's once. So yeah, I want to say it's n by n time because we go over each element in the matrix. Or n time if we just consider it as one large array. I knew you could. I was thinking about the bitwise. Yeah, it looks like we could have just ORed it with a 1. And it would have flipped it. That is unfortunate. So need to. I think the next one is count items matching a rule. So you're given an array items where each item sub I is equal to type sub I, color sub I, name sub I. Describes the type, color, and name of the ith item. You're also given a rule represented by 2 strings. You are given an array items where each item sub I, type sub I, color sub I, name sub I. Describes the type, color, and we pretty much have an array of triples. You're also given a rule represented by 2 strings, rule key and rule value. Is this a tuple? No, we're just given 2 more parameters. The ith item is said to match the rule if one of the following is true. Rule key equals type and rule value equals type. Oh. So it's a key value pair basically. Basically, an item can only match one of the rules. Since the item can only match one of the rules, and we're supposed to return a number. It looks like we just have to do CT equals 0. What's the order again? Type, color, name of items. We'll say if saying if triple sub key equals rule value CT plus equals 1, where key rule key equals color, we'll say that the key is equal to 1. Then we can duplicate this and say if it's equal to name, then the key is equal to 2. Remove one element to make the array strictly increasing. Given a zero-indexed integer array nums, return true if it can be made strictly increasing after removing exactly one element, or false otherwise. If the array is already strictly increasing, return true. So it looks like we could pretty much get a number of mistakes. And if mistakes is less than or equal to 1, then we'll return that it can be increasing. Otherwise, we'll just iterate through the array -1, and we'll just say if num sub I is greater than num sub I plus 1, then we'll say mistakes plus equal 1. Wait a second. I wanted to do it in linear time, but there is a solution in log n time, but log n time. 2, 3, 1, 2. I think I'm returning 1 because I think we just need a slightly better way, but I think we still might get got. No, I think we should be fine. We're saying if num sub I is greater we can add another one, or, and we'll start actually at I is equal to 1 now, or nums sub I is less than nums sub I minus 1. Right, if I'm at 1 and I'm less than 3, then that's also an issue. Output was false, they expected true. Maybe I'm underthinking this. What we could do instead is to have a while loop we'll let I equal to 1. We have 1, 2, 10, 5, and 7. 1 is less than 2, 2 is less than 10, but 10 is not less than 5. So if we remove 10, it would be good. We say 2 is less than 3, 3 is not less than 1, 1 is less than 2. If you remove 3, right, then 2 is still not less than 1. I think the issue is that every number once we find a place where we don't agree, we have to make sure that every number before that number is less than it. So I think we could switch this whole thing up if we just use a history array. You can just iterate over, and this, I think this would be in n squared time with linear space. So we'll say if num sub I is greater than num sub I plus 1, then we have a problem. And so what we'd like to do is, the first thing we'll say is mistakes plus equal 1, and also we'll say for const num of history, if there are any other numbers we've already seen that this also happens to, otherwise we'll just do history dot push nums sub I. Another thing we'll do is if mistakes greater than 1, we'll just return false. I shouldn't click run, but I'm doing it anyway. Oh, it's not strictly increasing. Okay. So we just need to change this to equal. Or remove 105.924. I think I'm not thinking. I think I'm just trying to rush for this problem. I just need to slow down and actually think. What's the actual style? We have 105. Is 105 greater than 924? No. Is 924 greater than 34? Yes. That's one mistake. Now you want to make sure. The mistake would be removing 924. That will allow. The only other check is 105 greater than 32. It is. But they're saying you can remove one number to make it strictly increasing. I think we're overcomplicating this. And I think what we need to do is just actually brute force it. And what we'll do is on the inner array, on the inner loop, we'll just check all the numbers in the array, right? But we'll skip if m equals I, or we'll only do it when m does not equal I. So we'll pretend like we're removing an element, and then we'll just say and we'll say if num sub I is greater than num sub I plus 1. If it's greater than it, for some reason I'm having trouble thinking. This is quite a simple problem. Num sub I is greater than num sub I plus 1. Yeah, why is this problem giving me hmm m does not equal I. If m does not equal I, m is the inner, and m plus 1. Count plus equal 1. I equals 0. M equals 1. If m does not is 1 does not equal 0, or m minus 1 does not equal I. So skip that and we go to 10. It's 2 less than 10. 10 less than 5. I think I see what's happening. Oh, I need to change this to next index, and that m is less than nums dot length. I don't understand. I can't believe this. Oh. I think you can do this in n squared time and space. I keep ending up with a complicated brute force version, and the brute force version should just be simple. Let me try one last time. Let R equal an empty array. R is going to equal to nums dot splice dot slice. Yeah, we'll come back to this one tomorrow. This one's a relatively simple problem, but I don't understand. Maybe my brain is fried or I'm frustrated.